with the same, that is triangles. Yeah. So R is, you was not there in the previous class. So just a brief introduction that today we are going to start the next exercise of triangle. The concept of congruency you already know. Here we are going to discuss about, yes, congruency again. And we are also going to take theorems that is related to isosceles triangle. Now isosceles triangle is a triangle where two sides are same. So if we are having a triangle, let's say triangle ABC. So there are three categories for triangle: scalene triangle, all sides are unequal; isosceles triangle, two sides are same; and equilateral triangle, the name says all about itself, all the lateral, all the sides are equal. So here we'll be focusing on isosceles triangle also, apart from the concept of congruency, where two sides of a triangle will be same, as we know about isosceles triangle. And you already know this theorem that when two sides are same, their opposite angle will also be same. Or when two angles are same, opposite to those angle, whatever sides are there, those side will also be same. So these theorem also frequently will be using, that since side are given same, angle will be same. Since angle are given same, side will be same. So let's start with the questions. So I'm going to take one of the question, that is question number 5 from exercise 7.2. Please do, you once you will understand question number 5 and the next question, after that we'll be discussing the next also. By yourself only you will be able to do the first few questions. So let's discuss this one and you try those questions by yourself. If you can't do, no worries, we will be discussing that in your assessment after the class, the assessment which you are going to give in the app. That assessment also, wherever you are feeling doubt, if the assessment in the while giving the assessment you are realizing that something is not so clear, please get back to me, I'll be discussing the same with you. Okay, so let's start. So here question number 5, here we are having one figure. Yes, Ifra, we are continuing with the same. And as I said to you, once we'll be done with this one, we'll start the Heron's formula. Okay.
Okay, ma'am.
Okay, so this is the figure we are having. Let me write the name of the given figure, that is A, B, C, D. This side same, and this side same. Let me write the given information over here. So the information given over here is ABC and DBC are two isosceles triangle. It's written, it's given that ABC and DBC are two isosceles triangle. And that's why the side which are shown, that two sides are equal, that too is already shown in the figure. Since it's an isosceles triangle, we must know which two sides are same. So here already it is given in the question, given in the figure, that okay, the single mark, this AB is equals to AC and this BD is equals to CD. So let's write that AB is equals to AC. It is already given, and it is also given that BD is equals to DC. Now what else is given? Show that we have to prove that angle ABD is equals to angle ACD. This is what we have to prove over here. Angle ABD is equals to angle ACD. whenever we have to prove anything in this triangle chapter, what we are thinking about, we are thinking about the concept of congruency. If that is not working, then we have to think about any other approach or something. So first thing first, we'll be thinking about the concept of congruency. Let's see whether it's working or not. If it will not work, then totally we will focus on other properties of the triangle, or maybe totally isosceles triangle. So let's see, here we are having angle ABD. This angle, the green one, is equals to the other green one. That's what we have to prove over here. How we'll be proving? We'll be taking such a triangle to such a triangle where that angle B and angle C must come. Now, if you will see both the upside one and the downside one triangle, you can see it. ABD is not coming over there. ACD is not coming over there. If you are going to take this green triangle and this is sky triangle, that might not work because we wanna prove that ABD is equals to ACD. So this two triangle, even if we will take and prove the congruency, it may not work. Okay, so we have to take such a triangle where this angle and that angle must come, so that we can say by CPCT this and that are equal. Okay, so if I will do one construction by myself, if I am going to join this one with D, like this one, this is the construction we are doing. Okay, we are free to do the construction. We are free to do any line. We can stretch it, we can draw it, and we can write it. We have constructed or we have joined A with D. Okay, so if we will do this construction, we have to check whether it's possible to prove that this triangle, the left side one and the right side one, both are congruent or not. So let's see whether it's possible or not to show these two triangles are congruent or not. But before that, we need to mention that we have done one construction. So let's write it. We have joined A with D. Okay, now we want to take triangle ABD and triangle ACD. Let's see whether it's possible or not to prove the congruency. So ABD, ACD. Okay, here we can see that AB is equals to AC. From where? It's given already. So I'm gonna write that AB is equals to AC. From where I am writing this one? Because that is given already. Now what else? Now the downside one, I can see BD side is equals to CD side. Let's write it. That too is also given. BD is equals to DC. BD it is equals to CD or DC, whatever. That too is already given from the isosceles triangle condition which was given. We have got this one. Now what else? So can we say AD is equals to AD because both the triangle is having one common side, that is AD? Yes, we can say that. Let's write it. AD is equals to AD. Why? Because this one is the common side. Now we can see AB, BD, AD. Let's mark it. What I said to you, we are having two triangles over here. Which two triangle? I am talking about this triangle and I'm talking about this triangle. Okay, these are the two triangles which we have taken. Now what I said to you, once you will list down everything, just get back to any one of the triangle, either the green one or the sky one, and mark everything whatever you have used to equalize from the given information, or by yourself also. If you have taken any information, then please mark it. So I have taken this side, I have used this side, I have also used this side, and I have also used this green side. So can you see the sequence? Side, side, side. Is there rule which says side, side, side rule? Is there any rule like that? Let's see whether we are having any rule like that or not. Can you see here we are having the list of rule, and the first rule is only side, side, side congruency rule. So yes, that rule exists. If that rule doesn't exist, then we have to think about something else. But that rule exists. So we can say both the triangles are congruent with each other. Here we can say that triangle ABD is congruent with triangle ACD. But what I said to you, when you are giving the name of the triangle all by yourself, please do confirm that you are writing the sequence of the name properly or not, because on the basis of the sequence of the name only you will get to know which sides are corresponding side, which angles are corresponding angle. So how you will understand what will be the sequence of the name? Just with the help of given information, the information, three information which you have listed down, just with the help of that you will be able to get to know what will be the name of the triangle. So here in our information it was AB is equals to AC. I have written AB, AC on the same place. Till now we are well and good. Let's go ahead and check. BD is equals to CD. BD is equals to CD. Okay, now also we are on the right track. Next one, AD is equals to AD. Can you see AD is equals to AD? So yeah, our name is perfect. What we wanted to prove? We wanted to prove that ABD, angle ABD is equals to angle ACD. That means angle B from here is equals to angle C from there. Let's see our sequence or the name of the triangle is suggesting the same or not. So ABD is equals to ACD. If you will look at the name of the triangle carefully, just a moment. Yeah, if you will look at the name of the triangle carefully, here angle B is equals to their angle C. So we can see B and C, yes, both the angles are same by CPCT. So let's name it. We can say angle ABD is equals to angle ACD. How? By CPCT, because both are corresponding part of congruent triangle, and hence we are done. Okay. So we have totally, here we have used the concept of congruency. Okay, isosceles triangle, equal sides, everything was mentioned in the question. It was given in the question that it's a isosceles triangle, but the side which are same, that was marked in the figure only. So that marked side I have copy pasted over here. Okay, so we have not taken any other condition, just totally we have used the concept of congruency. Let's do the other one. Is it clear to everyone? Is it clear to everybody?
Yes, ma'am.
Okay, let's go ahead. So now we are going to do question number 6. That says, let me draw the figure at first. A, B, C, D. This. Yeah. Here it says triangle ABC is an isosceles triangle in which AB is equals to AC. So it is given that AB is equals to AC. Why? Because ABC, triangle ABC is an isosceles triangle. What else is given over here? It's given that side BA is produced to D. That means side BA is extended till D such that AD is equals to AB. So here we can see AD and AB are same. Yeah. Show that we have to prove that angle BCD is right angle. We have to show that angle BCD is 90 degree or right angle. So how can we prove that? Let's see. Here also we can start with the concept of congruency. But what you will do by proving the congruency of this triangle and this triangle? Do we need to show two angles are same? No. Do we need to show two sides are same? No. We have to show 90 degree. So even if we will prove that this triangle, that triangle are congruent, we will only be able to say that this angle, that angle are same, right? 90 degree condition might not come, right? Because congruency, byproduct or the result of congruency is what? When you are saying this triangle, that triangle are congruent, then the byproduct, the extra information which we will be getting from there is this angle is equals to that angle, those angle is equals to those angle. So corresponding angles will be getting, corresponding sides will be getting. But here we don't have to show that the two angles are same, or we don't have to show two sides are same. We have to show that BCD is right angle. We have to show that angle BCD is of 90 degree. So the concept of congruency may or may not work over here. Okay, so we have to think about the other approach. Why we are going to think about the other approach? Because the same reason what I said to you. Okay, so what can be the other approach? So now only we learned in this chapter that apart from congruency, we are having one more properties or theorem in hand. Those are related to isosceles triangle. So here it says AB is equals to AC. AB, side AB is, if side AB is x centimeter, side AC is also x centimeter, right? Similarly, it also says that AD is equals to AB. So AD is and AB both are same. So if AB is x, AD has to be x only, right? Now, if we will focus on triangle, if we will focus on this triangle, the green one, the green triangle, here AB is equals to AC. So can I say angle ABC is equals to angle ACB? Angle opposite to equal side will be equal. Can I say this? Yes, we can say. That's what the property of isosceles triangle says. That if two sides are same, opposite angle will be same. If two angles are same, opposite to those angle, whatever sides are coming, those side will be same, right? So we can say that. What about this sky triangle? Sky triangle. Here we can see that in this sky triangle, two sides are same. That is AD and AC, right? So if AD is equals to AC, here we can see, we know in triangle ABC, AD is equals to AC. And since these two sides are same, opposite to these two sides, opposite angle will also be same, right? So angle ACD must be equals to angle ADC, right? Again, the same explanation, that is angle opposite to equal side are equal with each other. Yes or no? So eventually what are we saying? We are saying, let me write it. Yeah, we are saying that this angle and this angle are same. So if this is y angle and this is also y, like both will be equal with each other. That's what we have written over here. Here. Now in the sky triangle, what we are saying, in the sky triangle, we are saying that this angle is equals to this angle. So if that is z, this is z. Yes or no? Are you getting it?
Yes, ma'am.
Now if we will take the total triangle, that is triangle DBC. The complete triangle I'm talking about, not about the smaller one. I'm going to talk about now this triangle. Triangle D, here B, C. Okay. If we will be talking about this triangle, then we can say angle sum property of a triangle says the sum of all the interior angle will be 180 degree, right? This total angle is y plus z. This angle is y only and this angle is z only. You can match it over here. Okay. Z and y are nothing but just the variable. Whatever we don't know, we can assume it. Let's say this is x, let's say that is y, just like that. So angle sum property says that sum of all the interior angle of this triangle will be 180 degree. Yes or no? So we can say that y plus z plus z is equals to 180 degree. From where are we writing this one? From angle sum property we are writing this one. Okay. Now from here only, don't worry, we'll be doing it freshly also. Here just I'm explaining the concept. So here we can say that implies that 2y plus 2z is equals to 180. And that implies y plus z. If 2 you will take out as a common factor, that means 2 is going out. This implies 2 you are taking as a common factor and y plus z is equals to 180. And from here we can say that y plus z will be 180 by 2, that is 90 degree. Can I say? Everyone, are you getting it? This part?
Yes.
Yes, Ariz and Sumera.
Yes, ma'am.
Is it clear? So let's do it freshly. Okay. So we have listed down everything. Now we will say in triangle BCD or DBC, whatever, angle D plus angle B plus angle C is equals to 180 degree. Why? From angle sum property of triangle. Here, angle DBC can be written as, let's say, here I have assumed the green one was Y. Here I have assumed this 2 is Z. Okay. So I can say angle D is Z, angle B is Y, angle C is total Y plus Z is equals to 180. Okay. From here we'll be getting this 2y plus z and z will 2z is equals to 180. 2 common out, y plus z is equals to 180, and from here we are getting y plus z is equals to 90 degree. What we wanted to prove over here, we wanted to prove that this complete angle, this purple one is of 90 degree. That means purple one, if I am removing the purple mark, can you see this is y plus z only? Can you see? This is y and z only. So y plus z already we have got 90 degree. Hence we can say, can you see y plus z is 90 degree? Hence we can say angle BCD. Therefore, angle BCD is right angle. Is it clear to everyone? Yes. So Mera, is it okay? Okay. Okay, let's continue. So here the next question is question number 7, which says triangle ABC is a right angle triangle. ABC is right angle triangle in which angle A is of 90 degree. So I am drawing a right angle. Angle A, I am marking it here because it says angle A is of 90 degree. And the name is ABC. It is given that angle A is 90 degree. It is also given that AB is equals to AC. AB, where is AB? This one. AC, where is AC? This one. Okay. It's given that AB is equals to AC. So we can say, okay, what we have to prove first, write it. Here we don't have to prove anything. We have to find angle B and angle C. Again, without using the concept of congruency, we can go ahead and we can find the required angle. That is B and C. Okay. How can we do so? So if we know angle B, AB is equals to AC, from here, can we say that angle opposite to equal side are equal? So opposite to this one, this angle, opposite to this one, this angle. Okay. So let's write it. I want to say that since these two sides are same, hence angle BCA will be equals to angle CBA. Again, angle opposite to equal sides are equal. Okay. Now, once we got that this angle and this angle are same, let's say it's x only. Okay. I'm going to write over here, let's say x is equals to x. Let's consider. So now again in triangle ABC, what we can say, sum of all the interior angle will be of 180 degree. So x plus 90 is equals to 180 degree. And from here, easily we will be able to get a, just take out the value of x. That is twice x is equals to 180 minus 90. That means twice x is equals to 90 and x value will be 45 degree. So what is angle B? Angle B is x, that is 45 degree. What is angle C? Angle C is also x, that is 45 degree. So we found it, whatever was asking in the question. So just with the help of isosceles triangle property, two sides were equal. One is 90 degree. So if two sides are equal, both the opposite angle will be equal. Now, if one is 90 degree, then just by angle sum property, we can say that the sum of interior angle will be 180. And from here, we will be getting the value of x, that is each and every unknown angle, right? Is it clear to everyone?
Yes, ma'am.
Okay, let's go ahead. Now, the last question from this exercise is question number 8, which says, let me see, which says that show that the angle of equilateral triangle, show that the angles of an equilateral triangle are 60° each. Okay, we already know equilateral triangle means all sides same. If all sides same, then all angles same. All angles same, then 60° each. We already know that 60, 60, 60, and that will make 180° angle sum property. But here we are supposed to prove it. Okay, so let's say we are taking a triangle ABC. ABC. Okay. Now, since it's an equilateral triangle, all the lateral will be equal. Lateral means sides. So since ABC, let me write it. How we will approach this question, let me write it in detail. So let ABC is an equilateral triangle. Where AB is equals to BC is equals to AC. Okay. AB, BC, AC all are same. That's it. Now we want to say, now only in this chapter we have learned that if two sides are same, angle opposite to those two sides will also be equal with each other. So here I want to use, we are not going to use equilateral triangle property or anything. We are going to use the isosceles triangle property, which says if two sides are same, their opposite angle will also be same. So I want to say, since, just a moment. Yeah, I want to say, since AB is equals to BC, okay, AB and BC, two sides are same. Now, opposite angle must be same. Therefore, what is the angle opposite to AB? So, if this is side AB, opposite angle is this one. And what I have taken, AB, BC, I have taken BC. So, this angle will be same. So, I want to write, therefore, AB, angle ACB is equals to angle BAC. Why? Because now only in this chapter we have learned that angle opposite to equal sides are equal. So let's write it, angle opposite to equal sides are also equal. Now we already know that BC is equals to AC. We also know BC is equals to AC. Again, what is the angle opposite to BC? Angle A. What is the angle opposite to AC? Angle B. So I want to write angle A will be equals to angle B. So angle BAC will be equals to angle ABC. Again, the same explanation. Angle opposite to equal side will be equal. From equation 1 and equation 2, from equation 1, and this is, let's say, equation number 2, we are getting that all the three angles are equal with each other, right? From 1 and 2, we can write from 1 and 2, all three angle ACB, BAC, ABC, all are equal with each other. So angle ACB is equals to angle BAC is equals to angle ABC. Let's say all three are equal and all three are equals to X. Now, in triangle ABC, angle A plus angle B plus angle C will be equals to 180°. Why? Because angle sum property of triangle says that whenever we are having a triangle, all the interior angle sum has to be 180. If it is more than 180, if it is less than 180, then we will not be able to draw a triangle. Okay, So when it's not 180, then you will not be able to construct a triangle. So all the interior angles sum has to be 180. Then and only then we will get a figure of triangle. So angle sum property of triangle. Here we can say x plus x plus x is equals to 180. That means 3x is equals to 180. From here we got x equals to 180 by 3. That means 60 degree. So x value we got 60 degree. That means each and every angle will be 60 degree. So we can say hence each angle of an equilateral triangle is of 180 is of 60 degree. Now let's review what exactly we have done over here. The explanation or the question says show that the angle of an equilateral triangle are of 60 degree each. Okay, we don't know about equilateral triangle. Still, till now we have learned about isosceles triangle. Equilateral triangle, we only know that equilateral means all lateral are same, all sides are same. That's it. Apart from that, we don't know anything. Okay. So with the help of isosceles triangle property, first we are taking one triangle, that is ABC is an equilateral triangle. Since the name is equilateral, all sides are same. Now, isosceles triangle property says if two sides are same, their opposite angle will be same. So, first two side I have taken as a same and opposite angle also I have taken as a same. Okay. Now, the next two side, that is BCAC, also I have taken as a same. And then byproduct is opposite angle are same. So, opposite angle also I have written it. Since sides are same, opposite angles are same. Here also, since sides are same, opposite angles are same. Okay. Now equation 1 and equation 2 is just, you can see over here, it's giving us the liberty that all the three angles are equal with each other. ACB, BAC, here BAC is equals to ABC. So I can see over here that angle C, angle A, angle B. So all C, A, B, all are equal with each other. So that's what we have written, that all the angles are equal with each other. That is X. X, let's say. Now, angle sum property of a triangle, any triangle, scalene, isosceles, equilateral, any triangle you are having, angle sum property says that if you are talking about a triangle, the sum of interior angle has to be 180 degree. So since we are talking about a triangle only, so we can take a complete triangle ABC. We know all the angles are equal with each other. Now that means angle A, angle B, angle C is equals to 180. All are same with each other. And from here we got X value as 60 degree. That means each and every angle are same and each and every angle are of 60 degree. That's what we wanted to prove here. Is it clear to everyone?
Yes, ma'am.
Ma'am.
Let's go ahead. Yes, Sumera, is it clear? So this is how we are done with the second exercise. Okay. Today you will get the opportunity to give the assessment on second assessment based on second exercise. Okay. So once you will open the app, you will get the assessment section. It's live in your app. Let's continue with the same. That is exercise 7.3. I am taking the first question, very first question. Okay, let's see what exactly. Here also, more or less, we are going to talk about the concept of congruency, either the concept of congruency or the concept of this isosceles triangle and all. So let's see what exactly the question says. Let me draw the figure. Here one figure is given over here. Yeah. And the instruction given in the question says that triangle ABC and triangle DBC, ABC and DBC are two isosceles triangle. It's written that triangle ABC and triangle DBC are two isosceles triangle. Okay. On the same base BC. And vertices A and D are on the same side of BC. Okay. If AD is extended to intersect BC at P, show that we have to prove that the rest of the information are nothing but D is joined with P, A is joined with D, and all everything is written over there. That's why I'm not noting it down while writing the given information. Okay. What we have to prove here, we have to prove 4 parts. The first part says so that triangle ABD is congruent with triangle ACD. Okay. The next part says triangle ABP is congruent with triangle ACP. After that, the third part says AP bisect angle A as well as angle D. And the fourth part is also there, which says to prove that AP is perpendicular bisector of BC. Okay, let's prove it one by one. At first, we'll be focusing on the first part. Okay, let's see what exactly we have to do. So here, as you can see, all the 4 information, like the given information is ABC, DBC are two isosceles triangle. Since ABC, DBC are two isosceles triangle, we can write it over here that it is given that it's an isosceles triangle. So any two side we must take as a same, right? So ABC is isosceles. I want to say AB is equals to AC. Now DBC is also the smaller DBC. It's an isosceles triangle. So we can take DB is equals to DC. Okay. With the help of given information, we are writing this one. Now let's start with the proof. We have to prove the first part ABD, ACD. Let me mark both the triangle ABD and ACD. ABD. This is the triangle. And the next one is, this is chi 1 is the triangle. Can you see it? Now here, what exactly are we having same? Let's see what exactly are we having same. So we know we know here AB, this side is equals to that side. This side. The green one is equals to sky 1. What else we know? There is a common side I can see over here, which is common in the green and the sky 1. So let me write it. This is the common side. Okay. And what else we know? It is already given that DB is equals to DC. Okay. So this green one this side DB is equals to this side. So can you see we are getting the sequence side, side, side of this triangle is same as side, side, common side of that triangle. Are you getting it? Are you getting?
Yes, ma'am.
So we can say both the triangle are congruent triangle. Let's write it. Let's write all the information. I need to just remove everything so that in the next part we must not get confused. Yeah. Yeah. This was the given figure, exact figure. Okay. What we are going to write down over here, a triangle ABD and triangle ACD. We know that AB is equals to AC, given. We also know that DB is equals to DC. That too is given. And we are having one common side, that is AD over here is equals to AD over there. That is common. So we can say triangle ABD is congruent with triangle ACD by side congruency rule. Okay, this much we have already discussed. Now what will be the byproduct of this one? Byproduct means what is the extra information we'll be getting from here. As I said to you, that once you will prove the congruency, there will be corresponding side, there will be corresponding angle. Do we need those? Maybe we don't need those for now, but since we are having back to back 2, 3, 4 section which we have to prove, anytime anything we just maybe anything will be helpful from here. So let's list down everything whatever we are getting from here. So I'm making the list just for our information. You are not going to, you can also make the list in the exam, no worries. Nobody is going to deduct your marks for that. Even you may get extra marks. Okay, so for having that much knowledge and clarity about this topic. So here I am going to write that here angle A is equals to their angle A. So first I am going to write angle BAD is equals to angle CAD. Here angle B is equals to their angle C. Angle ABD is equals to angle ACD. And what else? Here angle D is equals to their angle D. So angle ADB is equals to angle ADC. All the corresponding sides by CPCT, these all are same. Okay. Why these all are same? By CPCT. We also we will get the corresponding sides which are same. So we already know AB is equals to AC. We also know BD is equals to CD. And we also know AD is equals to AD, like the common side. This much information we got from the congruency of the above case. We are keeping it in hand. Maybe it will be useful for the next part. So let me mark down everything properly so that we will not get confused. Angle BAD, angle CAD. Angle BAD, this angle and this angle are same. That's what we have written by CPCT. What else I have written by CPCT? I have written that angle ABD is equals to ACD. ABD, this angle, the blue one, is equals to this blue one, ACD. And what else I have written? Angle ADB is equals to ADC. Okay. This is just the explanation part. When you are going to do it, you can directly jump to the next proof. ADB This green one is equals to that green one. Okay, these are the information which we are having. Side also we are having same, that we already have listed down, no need to mark it. I am marking it so that we can go ahead, and while proving the next part, it will be easier for us to identify. Now the next part is triangle ABP and triangle ACP. Let me mark both the triangle now. ABP. ABP. I'm talking about this green triangle and that sky triangle. A, C, and P. Okay, this is what we are going to talk about, the green one and the sky one. Total green one, total sky one. Now ABP, ACB, let's see what exactly are we having same. So here in the green triangle, can you see that? Can you see this side is same as that side AC? This side. We also can see here that this red angle is equals to, I'm talking about this red angle, okay? This angle is equals to that angle. Can you see? In both the triangle, angle are same. And what else? This side, AP is a common side. Can you see it? AP is a common side. Can you see my cursor? Everyone? Are you
Yes,
there?
ma'am.
Any confusion, Sumaira and Aris? Any confusion? Okay. Who said to you not to speak, Sumaira? Like, is there anything going on at your home? Yes, Sumaira? Anyone said to you anything? What happened? You can speak in my class. How I will get to know whether you are getting or not? Okay. That may be due to any technical issue. That that won't be the case. Sometimes I even don't get the permission to speak. So that's not how it designed. Like sometimes I have, like I face such problem, but that is just technical issue. Okay, no worries. I will be fixing. I'll be telling them to fix it from the next time, because I want my students respond like in each and every question, then and only then I can go ahead. So that can be technical issue. Sometimes I also join and I don't even whatever I am saying, hey everybody, are you okay? I This is the explanation, are you getting it or not? And everybody just say, ma'am you are not audible, ma'am you are not audible, just like this. Then I have to leave and join, leave and join. So that can be any technical issue. Please don't worry, that can't be the case. Okay, I'll be informing them about this issue. So yeah, so this is how we will get this side angle side. That's why I was marking with red color, the this blue color, every information which we have got from the first case. Okay, now let's just a moment. Okay, it's already, the time is over. Just a moment. Okay, so we can, whatever I have said to you, for triangle ABP and ACP, you can take you can take over here ABP and ACP. Okay, you can take here that ABAP, the common one, and this angle BAP is equals to angle CAP. This is how we will be getting side angle side congruency rule. Okay, I'm talking about this side, I'm talking about this angle, I'm talking about this side. You can see side angle side congruency rule says that this two triangle will be congruent with each other. Okay, so easily we will be able to prove the second part. Now what about third and fourth